All right, so you've probably used an AI like ChatGPT, right? And you ask it a question and it just answers in this perfectly human-like way. It's kind of spooky, but it's also amazing. So, have you ever stopped to wonder, how does it actually do that? Well, today we're going to pull back the curtain on that very magic. We're going to break down, step by step, how a computer learns to understand and speak our language. So, here's our game plan. First, we'll tackle the big problem. Why is human language so hard for a computer? Then we'll see how it chops up text into tiny pieces called tokens. After that, we get into the really cool part, how words become numbers. Then we'll talk about the attention revolution, which is a total game changer. And finally, we'll see how it all boils down to one simple task, just predicting the next word. All right, section 1, the AI language challenge. So first things first, we really have to appreciate just how ridiculously hard this whole thing is. I mean, think about it. Our language is just packed with nuance, sarcasm, and ambiguity, things that we get without even thinking. But for a computer, it's starting from zero. It has to learn all of that from scratch. Okay, look at this sentence right here. The judge issued a sentence. Simple enough for us, right? But for a computer, the word sentence is a huge problem. Does it mean a line of words, or does it mean a prison term? The only way the computer can figure it out is by looking at the other words. Judge, issued, okay, it's a legal penalty. And that right there is the fundamental challenge. For a machine, context isn't just important, it is everything. And solving that exact problem is the whole reason a special field of AI exists. It's called natural language processing, or NLP for short. And its entire mission, this massive, ambitious goal, is to teach computers how to understand and use our language with all of its messy, beautiful complexity. Okay, next up, from text to tokens. So here's something that might surprise you. The very first step an AI takes has nothing to do with meaning at all. Before it can even try to understand what a sentence is saying, it has to chop it up into smaller, more manageable building blocks. And that chopping up process, it's called tokenization. The AI takes the text and breaks it into these little pieces called tokens. And check this out. A token isn't always a whole word. The word transformers here gets split into transform and ers. Now, why would it do that? Well, it's actually really clever. It helps the model understand and build new words it's never seen before, just by knowing the parts. So how does it decide what becomes a token? It's through a pretty cool training process, often something called byte pair encoding. It's actually simpler than it sounds. So, step 1. It starts with a dictionary of just single characters, A, B, C, and so on. Then step 2. It reads a gigantic amount of text and finds the pair of characters that shows up most often. Let's say it's T and H. Step 3. It merges T and H into a single new token and adds that to its vocabulary. And then step 4, it just does it again and again and again, finding the next most common pair, maybe and merging it. It keeps doing this until it has this super efficient vocabulary of common word parts and full words. All right, part 3, words become numbers. So we've got our text broken down into tokens. That's great, but there's a problem. Computers are, at their core, just number-crunching machines. They don't understand love or transform. They only get numbers. So the next critical step is to translate these tokens into the language of math. And the way they do this is with something called embeddings. It's a fancy word, but the idea is straightforward. Every single token gets turned into a long list of numbers. This list is called a vector. You can kind of think of this vector as a set of coordinates locating the word's meaning in a giant high-dimensional map. So here, dog gets one set of coordinates and car gets a completely different set. Now, this is where it gets really, really cool. These numbers, they're not random at all. As the AI trains, it learns to assign these numerical coordinates in a way that actually captures meaning. So words that are similar in meaning, like mortgage and loans, end up being close neighbors in this giant map of meaning. You can see them clustered together here. And that's how the AI starts to understand that some words are related and others aren't. It's all about proximity in this mathematical space. This whole idea of embeddings is a complete game changer, seriously, because once words are numbers, you can do math with them. You can literally do meaning math. The classic example is this. You take the vector for king, subtract the vector for man, and then add the vector for woman. And guess what? The result is a vector that's incredibly close to the one for queen. It's wild. This is how the AI can understand analogies and relationships, all through arithmetic. Okay, moving on to section 4, the attention revolution. We have numbers for words now, which is awesome. But a word's meaning can totally change depending on the words around it, right? So how does an AI figure out the context of a whole sentence? Well, that brings us to a truly revolutionary concept called attention. To really get why attention is such a big deal, you have to know what came before. So pre-2017, AI models read text kind of like we do, one word at a time from left to right. The problem was, if they were reading a really long paragraph, by the time they got to the end, they'd sort of forget what was at the beginning. They struggled with long-term memory. Then, in 2017, a paper with the amazing title Attention is All You Need came out, and it introduced the transformer. This new model could look at all the words in a sentence at the same time, and that changed absolutely everything. The secret sauce of the transformer is this incredible mechanism called self-attention. And what it does is, for every single word in a sentence, it looks at all the other words and asks, okay, which of you guys are the most important for understanding me right now? It dynamically weighs the importance of every other word to build a rich, contextual understanding. So how in the world does that actually work? Okay, let's break it down with a simple analogy. Imagine every word in a sentence is a person at a party, and one word wants to understand itself better in the context of the room. So it creates three things for itself. First, a query vector. Think of this as the word shouting, "Hey everyone, I'm looking for information related to this." Then every other word in the room has a key vector, which is like their name tag saying, "I've got information about that." The model then compares the query to every key to see how well they match up. The better the match, the higher the attention score. Finally, each word also has a value vector, which is the actual substance, the actual meaning it has to offer. So based on those attention scores, our original word takes a little bit of value from everyone, but it takes a lot more from the words that had a high score. It blends all that information together, and voila, it has a brand new, super context-aware understanding of itself. And now for our final section, predicting the next word. So let's recap. We have tokens, we have number representations for those tokens, our embeddings, and we have the amazing attention mechanism to figure out context. So what's the goal of all this machinery? You might be surprised by how simple the answer is, but it's also what makes the whole thing so incredibly powerful. It's almost hard to believe, but this whole incredibly complex system is trained to do just one thing: predict the next word in a sentence. That's it. During its training, the model is shown billions, even trillions of sentences from the internet, from books, you name it, but with the last word hidden. And its only job is to guess that missing word. So if the model sees Mary had a little, it then has to calculate the probability for every single word it knows. It might come up with, say, an 85% probability that the next word is lamb. But maybe there's a 3% chance it's car and a 2% chance it's floor. When it guesses lamb correctly, it gets a sort of digital pat on the back. Its internal wiring gets adjusted just a tiny bit, reinforcing that correct prediction so it does even better next time. And this is the most mind-blowing part of the whole story. To get really, really good at this one simple task of predicting the next word, the model has no choice but to learn, well, everything. It's forced to learn grammar so its sentences make sense. It has to learn facts about the world because how else would it know that after the capital of France is, the most likely word is Paris? It learns reasoning, it learns style. All of this incredible, complex knowledge just emerges as a side effect of trying to get that one simple prediction right, over and over again. So that leaves us with a really big, kind of philosophical question. If an AI is just predicting the next most statistically likely word, is it really understanding what it's saying? Or is it just the world's most sophisticated parrot? An incredible pattern-matching machine that has seen so much text, it can perfectly mimic conversation without any real comprehension underneath. Is it true intelligence? Or is it just a very, very convincing illusion? That's definitely something worth thinking about.